Yes. Yes, we have
Yes, sir.
integrated RNA equation.
So the differential form of the NH equation was d upon dt of ln k is equal to E upon RT square. And if we so d ln k will be E upon R t square dt. If we integrate on both sides from k1 to k2 and t is equal to 0 to t. So what we have is ln k2 minus ln k1 will be E upon R minus 1 upon t. Time will be t1 to t2. Sorry, sir. t1 to t2. So ln k2 upon k1 will be E upon R 1 upon t1 minus 1 upon t2. So it will give me ln k2 upon k1 E upon R t2 minus t1 upon t1 t2. So this is the derivation of the Arrhenius equations integrated form, sir.
Yes, good. Yes, what the slope of log k versus 1/2 in RNA equation?
Yes. So as d ln k is equal to E upon RT square dt. So if we integrate it without limits, sir, ln k will be a minus E upon RT. A is the integrating constant, and if we plot the graph between ln k and 1 by t, the graph will be like this, where slope will be minus E upon R and intercept will be the integrating constant, which is a in this case.
Yes, good. Yes, any drawback and limitation of RNA equation in chemical kinetics?
Hmm. So I'll read about it.
Okay. Yes, I send in group. Yes, WhatsApp group. All limitations of thermodynamics, kinetics, and other topics. Yes.
Yes, sir. I have added to that group yesterday. So the questions of the kinetics were shared before I was added to the group, I think, sir.
Yes. Okay.
Because
Yes, I will
yes, sir.
send you in your personal chat. Yes, no.
Okay, sir.
The next topic is catalysis. What is catalysis? What is the
Mm.
main application of catalysis in chemical
Mhm.
kinetics?
So catalyst is a chemical substance which is used to change the rate of the reaction. Uh, uh, Generally to increase the rate of the reaction. So if let us say a reaction is very slow or the rate of the reaction is very less, so catalyst is added to increase the rate of that particular reaction.
Yes. What the relation between catalysis and activation energy, Arrhenius equation?
So what a catalyst does is that it changes the activation energy. For example, a reaction proceeds like this. We have reactant here. This is the energy and product here. So without catalyst, the reaction proceeds like this. This is the activation energy. But with addition of catalyst, what catalyst does is it decreases the activation energy for the reactant without changing the product. So after the addition of catalyst, the activation energy will be A dash, which is less than the activation energy which is without catalyst. So catalyst is the working of the catalyst is that it helps in decreasing the activation energy of the reaction so that the reaction proceeds at a faster rate.
Yes. What the derivation of any derivation? Any formula?
Sorry, sir. I don't know any derivation or any formula for catalyst.
Yes. What will be the effect of temperature or reaction rate in catalysis? Any effect?
Effect of temperature.
Yes.
So generally, sir, on increasing the temperature, the rate of the reaction increases as the number of collisions between the reacting molecules increases due to the high thermal energy provided by the increase in the temperature. So there will be more, the kinetic energy of the constituent particles of the reaction increases. So the rate of the reaction increases with the increase in the temperature.
Yes. Now, what will the effect of pressure?
Effect of pressure.
Yes.
So, sir, if we increase the pressure, so if we increase the pressure, then the volume should decrease to maintain the equilibrium constant. So, if we increase the pressure, the equilibrium reaction shift to that direction which have lesser number of moles. So for example, if we have a reaction like this, 2A gives me 3B, then on increasing the pressure, reaction will move in the backward direction. Or we can say that KB backward rate constant increases.
Yes. Yes.
Yes, sir.
The next question is steady state approximation. What the main application
Hmm.
of steady state approximation in chemical kinetics?
Yes, sir. So let us assume that a reaction proceeds like A gives me B, and from uh, B is the intermediate, and the final product is C. So steady state approximation, according to steady state approximation, the concentration of the reactant or the concentration of that particular compound is assumed to be constant. Like that, sir, if B is the intermediate, then according to steady state approximation, the concentration of B is constant. And sir, generally it is possible when the rate of conversion from B to C is very much high, or we can say that if K2 is much greater than K. Mhm. Hello, sir. Am I audible?
Yes, yes, what do you will now? Yes.
Yes, sir. So if the value of K2 is much greater than K1, that is, as soon as the intermediate B is formed, it is converted to C. So we can say that the concentration of B is approximately constant, and this is the condition of the steady state approximation, sir. That is, the concentration of that particular compound is assumed to be constant. Now, if we differentiate its concentration with time, it will be equal to 0. And so this method is helpful in deriving the relation between the different rate constants and to get the value of the rate of the equation.
Yes. Di upon dt is equal to 0. What the uses of these one in steady state approximation? What the main purpose?
Hmm. So the main purpose is to determine the value of the rate of the reaction. If we consider, if we apply steady state approximation on any intermediate, for example, hello,
Yes.
sir, I think the app is crashing again and again,
I
so that is why
yes, I think it's network problem, network issue.
ये भी हो सकता है सर,
Yes, आपके
क्योंकि
साइड
बार बार ऐप अपने आप बैक है और फिर अपने आप स्टार्ट हो जाती है।
वो नेटवर्क के कारण होता है। आपके साइड से मेरे यहाँ पे
अ,
नहीं। नेटवर्क कभी प्रॉब्लम होती है तो हो जाता है। कोई नहीं, चलने दो, कंटिन्यू। यस।
हो सकता है सर। सो सर, जो इक्वेशन हम जो मैथमेटिकल इक्वेशन हमें मिलेगी अगर स्टडी स्टेट अप्रोक्सीमेशन लगाएं किसी भी इंटरमीडिएट पे, वो मैथमेटिकल दैट पर्टिकुलर मैथमेटिकल इक्वेशन विल हेल्प will be very helpful in determining the rate of the reaction. So steady state approximation is used to calculate the rate of the reaction in a more simplistic way.
The next is equilibrium approximation. What is equilibrium approximation?
Equilibrium approximation is just like the steady state approximation. If we have, for example, let's say if we have two equilibriums, one from A to B and B to C. A is the initial reactant and C is the product with K1 rate with equilibrium constant K1 and K2. Now, sir, if the value of K1 will be much greater than K2, or value of K2 is less as compared to K1, then the steady state approximation and the equilibrium approximation behaves same mathematically. Otherwise, the equilibrium approximation states that the this reaction is like this. It is the forward rate constant, backward rate constant, then K1 will be equal to Kf upon Kb. K will be equal to Kf upon Kb, and the equilibrium approximation, according to equilibrium approximation, the equilibrium depends on the rate of the forward reaction and the rate of the backward reaction, and doesn't depend on the amount of the reactant and product formed.
Yes, what is the difference between steady state and equilibrium approximation? What the main difference?
What is the main difference? Sir, the major difference is that according to steady state conditions, the uh, concentration of that particular intermediate is assumed to be constant. It doesn't change with time, but such conditions not. So the major difference is that in the steady state approximation, the amount of intermediate is assumed to be constant. It doesn't change with time. But no such condition is present in case of equilibrium conditions.
Yes, steady state approximation di upon dt is equal to 0. Yes.
Yes, sir.
Life is short. minimum sort, negligible, yet doesn't exist. Rate determining state is doesn't exist in a chemical kinetics. Equilibrium
Okay,
approximation
sir.
intermediate is so many intermediate. Rate determining state is exist. वो एग्जिस्ट करता है, वो एग्जिस्ट करता ही नहीं है बिल्कुल. द मेन डिफरेंस. यस ना.
Okay, sir.
नेक्स्ट मूव ऑन नेक्स्ट थ्योरी. Yes, I am audible.
Yes, sir. Yes, sir. Now you are audible.
Yes, next topic is Lindemann theory. Yes, what are the main application of Lindemann theories in chemical kinetics? Explain.
Lindemann theory.
Yes, do you have any idea what Lindemann?
Actually, sir, I have devised the topic chemical equilibrium today.
It's a chemical
So the
equilibrium.
last time when yes, sir, the last time when I had studied kinetics was at the time of gate. After that, I haven't touched the chemical kinetics. So I need to brush up my knowledge once more.
Michelmanson, do you have any idea what Michelmanson equation? Enzyme catalyst?
Yes, sir, yes, sir. I have.
Yes, what the
I
main
can drive.
application of
Yes,
Michelmanson?
sir. So Michael Manson constant is used in the unimolecular. Hello, sir. Am I audible?
Yes, audible now. Yes.
Yes, sir. So it states that the Michael Manson constant was used in the unimolecular theory, which states that the when two molecules of same type collide, they will form a they will go to the excited state, and that excited state molecule will leads to the formation of the product. So we can say that if the forward. सर एक मिनट रुकना सर, मैं दोबारा एरोप्लेन मोड लगा के ज्वाइन करता हूँ सर.
Yes, yes.
Hello, sir.
Yes,
Yes, sorry for the disturbance, sir. I don't know what's happening with the network today.
no problem. Yes, carry on.
Yes, sir.
Well, let me start with the differentiation.
Yes. So the excited part of that particular constituent will gives me the product P. So if I need to calculate the rate of the reaction, then it will be minus dA by dt is equal to K1 A square, or this is also equal to K A star d by dt of A star. Also dA star over dt is equal to minus dA star over dt is equal to dA over dt is K minus 1 A star. So if I write it in two forms, A plus A, K1 A star to A plus A star will give me A plus A. First equation, second equation, and this is the third equation. So this rate equation is from the first equation. This is the rate equation corresponding to second equation, and the rate equation corresponding to third equation is minus dA star over dt is equal to dp over dt is equal to K2 into A star. Now if I need to calculate the rate of the reaction, which will be equal to dp over dt K2 into my A star, I need to calculate the value of the A star, which can be calculated by using the steady state approximation on A star. So according to steady state approximation, the concentration of A star is assumed to be constant. So d over dt of A star, that is differential of A star, will be equal to 0. So from using equation uh, first, rate equation corresponding to equation first, second, and third, this A, B, C, we can say that dA star over dt will be equal to minus K1 A square minus K1 A square plus K1 A square minus K minus 1 A star minus K2 A star, which is equal to 0. So K minus 1 A star plus K2 A star will be K1 A square. A star will be equal to K1 A square over K minus 1 A plus K2. So therefore rate will be equal to dp over dt is equal to K2 K1 A square upon K minus 1 A plus K2. So this is the rate of the equation for the unimolecular theory. Now as the rate is equal to K1 K2 A square upon K minus 1 A plus K2. So if we have to convert it in the form of Michael mention constant.
Yes.
Mention constant. So what we have to do is, sir, we divide this equation with just give me a second, sir. K1 a square k minus 1 a square into
Yes. If Km greater than substrate, then what will be the product? And Km less than substrate, then what will be the product? And Km equal to substrate, what will be the product of these reactions? Can we explain? What will be the order of reaction?
So, can you repeat the question?
Yes. First question,
If
Michael mentioned greater than substrate.
okay, if the concentration of Michael mention is greater than the
Substrate.
substrate concentration.
Yes.
Yes. So, but Km was K2 K minus 1 upon K1. So, rate will be equal to rate was equal to K2 into concentration of substrate into में concentration of E naught catalyst upon Km plus Ks. If Km is greater than Ks, rate will be K2 initial concentration of substrate and E naught plus divided by Km, because sir, Km plus Ks will approximately be equal to Km. So here is S. So if the concentration of if the value of Km is much greater than Ks, the reaction will be of second order, and if Km is less than the concentration of the substrate, or we can say that the concentration of substrate is higher than the value of Km, then in that case rate will be Ka into E naught. Actually, A substrate concentration is A. Numerator and denominator is A. So rate will be K into E naught. So sir, if the value of the Michael mention constant is less than the concentration of A, in that case the rate will be of first order with respect to the concentration of the catalyst. And if the value of Km is greater than the concentration of substrate, then the rate will be first order with respect to the concentration of substrate, and also first order with respect to the concentration of the catalyst, or we can say that overall it is a second order reaction.
Second order?
Overall it will be a second order reaction if the value of Km will be higher than the concentration of the substrate. and if the concentration of substrate is higher, then the reaction will be of first order.
Yes, Km is greater than substrate, then a first order of reaction. Yes, no?
If Km is greater than the concentration of substrate,
Yes.
then the reaction will be first order with respect to E naught, and also first order with respect to the concentration of the substrate.
Yes. And Km less than substrate, then what will be the product and order of reaction?
If Km is less than if value of Km is less than the substrate, then the reaction will be of first order with respect to the catalyst, concentration of the catalyst, E naught.
Yes. Km is equal to substrate concentration. So what will be the product and order of reaction?
So, sir, if Km is equal to A naught, as rate is given by K, A, E naught upon Km and A. So, if Km is approximately equal to concentration of A, rate will be K, A, E naught upon 2A, K, E naught upon 2. So rate will be equal to K into E naught upon 2. That is, it will be first order with respect to E naught, and its value will be equal to half of the value when the concentration of substrate is much higher than the value of Km.
Yes, good. Yes. The next day we will discuss left part of chemical kinetics. Yes, no? Lindemann theory, collision theory, activate complex theory,
Oh,
fast reaction, slow reaction, parallel reaction, conjugative reactions. Yes, no? Salt effect. Yes. Yeah, today
oh,
good luck. And from your side, yes. Good night and take care.
okay. Thank you, sir. Good night to you, sir.
Thank you.